So in the previous videos, we discussed the introduction part, that means basic terminology used in electrochemistry, and we derived the Nernst equation to calculate the EMF of the cell, then electrode potentials for anode and cathode. Now we are going to discuss about conductometric titrations. In general, if you take the volumetric titration, how can we calculate the endpoint? How can we know the endpoint? Just we are going to take some acid in the, if we consider basic acid-base titrations, if you take acid in the conical flask, we add base from the burette. To know the color change, here generally we are going to add indicator. Whenever the color change of the indicator, it shows that it is endpoint. This is about volumetric titrations. So in volumetric titrations, we know the endpoint using indicator. But coming to conductometric titration, here in conductometric titration, we are going to use, in conductometric titrations, we are going to measure the conductance of the solution. Here we are not going to use indicator. Simply by measuring the conductance of the solution, we are going to calculate the endpoint. Then what is conductance? What is conductance? Conductance of the solution. It is the ability of the solution. If we consider a solution in a beaker, now if we pass current through it, the solution is moving these electrons like this. Now it has the ability to flow the electrons in it. So the ability of the solution to allow electrons through it is conductance. What is conductance? The ability of a solution to flow electrons through it is conductance. Coming to the conductance, it depends on some factors. Let us discuss about the factors. If we consider a solution like acetic acid and HCl. One is strong acid and the other one is weak acid. If we pass electrons through these two acids, one is weak one and the other one is strong acid, which one will have higher conductance, either for weak acid or for strong acid? Generally, for HCl, the conductance is more when compared with acetic acid. Why? Because coming to the size of the acetic acid, generally it doesn't exist as ion like CH3CO minus like that. It initially exists as acetic acid. It doesn't have any ions to accept the electrons and to flow throughout the solution. Now coming to HCl, it exists as ion H plus Cl minus. Now if we add electrons to the solution, that H plus or Cl minus ions accept the electrons and it allows to flow through the solution. So coming to the factor which depend on conductance depends on is, first one is number of ions. For the weak acid like acetic acid, it doesn't exist as ion, so it doesn't have conductance. Consider another acid like HCl, it has ions, so it has high conductance because it depends on the number of ions. Now if this acetic acid, if we add some other ions to it like sodium or ammonium, now if we take, instead of this acetic acid, if we take ammonium acetate. Now this will have second factor. If we take ammonium acetate, it will exist as acetate ion and ammonium ion. Now same, if we compare it with HCl, which one will have higher conductance? Obviously for HCl, not for ammonium acetate, because even though it has equal number of ions, coming to the bulkiness of the ions, coming to the size of the ions, when compared with H plus and Cl minus ions, the size of the acetate ion and ammonium ion is more, so that it can't move faster in the solution. So coming to the mobility, this H plus ion is smaller in size and it is highly mobile, so it allows the electrons easily and fastly. Coming to the ammonium acetate, mobility of acetate ion or ammonium ion, it is slow, because coming to the mobility, they move slower due to their bulky size. Now what is conductance? Conductance is the ability of a solution to allow electrons through it is conductance. This conductance depends on what factors? First one, it depends on the number of ions. That means if number of ions increases, conductance increases. And also it depends on the mobility. If mobility of the ion is more, then obviously conductance of the ion is also more. Next, coming to the types of conductometric titrations, we have acid-base titrations, redox titrations, precipitation titrations. First, consider acid-base titration. First, consider acid-base titrations. Coming to acid-base titrations, we have different types of acid-base titrations. First one is strong acid versus strong base. How we are going to do this acid-base titration under conductometric titration? First, a conductivity meter is taken. Conductivity meter. It measures the conductance. How can it measure the conductance? With the help of a cell. We call it as conductivity cell. This cell measures the conductance. This is conductivity cell. If we dip this conductivity cell in a solution, this is magnetic stirrer. This is magnetic bead. It helps to stir the solution so that we can get even concentration. Now, how can we perform this acid-base titration? First, burette. In burette, we are going to add base, and in the beaker, we are going to add acid. Coming to strong acid and strong base titration, consider HCl as strong acid and NaOH as strong base. This is neutralization reaction and it gives NaCl plus H2O. First, acid is taken in the beaker and base is taken in the burette. If we add base continuously to the acid, then we are going to measure the conductance which is shown in the display of the conductivity meter. Initially, with the addition of base to the acid, means addition of NaOH to HCl, the conductance of the solution decreases. Initially, with the addition of base, NaOH, to the acid, to HCl, conductance of the solution decreases. Why the conductance of the solution decreases? Because this fast moving H plus ions are replaced by little bit slower moving Na plus ions, and this H plus and OH minus are going to become water molecule. So conductance decreases slowly, and after neutralization of HCl, if still we are going to add NaOH, then conductance of the solution increases as the number of ion increasing. If we plot a graph between volume of NaOH and conductance, initially with the addition of NaOH to HCl, the conductance of the solution decreases. After neutralization of HCl, the conductance of the sodium hydroxide increases. Why the reason? First, conductance decreases because here number of ions decreasing and fast moving ions also decreasing. And after neutralization, conductance increasing because the number of Na plus and OH minus ions increasing. So the intersection of these two lines gives the end point. This is the end point. In this way, we are going to calculate the end point for strong acid and strong base. Now, next one, strong acid and weak base. Previously, we have taken strong acid as HCl. Here we are going to take the same HCl. And instead of strong base, here we are going to take weak base. Example for weak base is ammonium hydroxide. This is also neutralization reaction and it gives ammonium chloride and H2O. Now, same setup. Going to measure the conductance with the help of conductivity meter by inserting the cell in the solution. Initially, we are adding base. Now, if we measure the conductance with the addition of volume of ammonium hydroxide. Initially, with the addition of base ammonium hydroxide to the acid, it is neutralization reaction, then it is going to form ammonium ion and chloride ion. So number of ions decreasing and also that ammonium ion number increasing. It is bulky ion and it doesn't have high mobility. So conductance decreases rapidly, and after neutralization of HCl, if we add ammonium hydroxide, the conductance remains constant. Why there is no change in the conductance here? Because this ammonium hydroxide doesn't exist as ions. It doesn't exist as NH4 plus and OH minus ion. It is existing as simply in unionized form. That means it exists as ammonium hydroxide. It doesn't have any ions. So there will be no change in the number of ions. So that conductance will remain constant after neutralization of HCl. If we plot a graph between the volume of ammonium hydroxide and conductance, we'll get graph like this. The intersection of these two lines will give the end point. Next, coming to weak acid versus strong base. Same setup, but we have to change the acid and base. If we take acetic acid as weak acid and sodium hydroxide as strong base, this is also neutralization reaction. It gives sodium acetate and water molecule. Now in the beaker we are going to take acetic acid, and in burette we are going to take sodium hydroxide. Now initially this acetic acid doesn't have any conductance because it is in unionized form. With the addition of sodium hydroxide to the acetic acid, it is going to form ions like acetate ion and sodium ion. Now consider the size of the sodium ion. It is bulky and it have less mobility. So with the addition of sodium hydroxide to acetic acid, of course conductance increases, but that increase is not rapid. it is slight increase. Why the increase is slight? Because this formed acetate ion is not a fast moving ion. It doesn't move faster in the solution. So the conductance increases slowly. And after neutralization of acetic acid, all the acetate ions are coming out. Till then, conductance increases slowly. And after neutralization of acetic acid, if we add excess sodium hydroxide, then concentration increases rapidly because the number of ions increases and the mobility is also more for sodium and hydroxide ion when compared with acetate ion. Now if we plot a graph between volume of sodium hydroxide and conductance, the graph will be like this. First slowly increase and then rapid increase. First, why the slow increase? Initially acetic acid doesn't exist as ionized, so the number with the addition of sodium hydroxide, it is giving acetate ion and sodium ion. So that increase in the number of ions. Increase in the number of ions means conductance increases. But why not rapid increase? Why slow increase? Because the released acetate ion is bulky ion. It doesn't move faster. So it moves slowly in the solution. That's why conductance increases slowly. After neutralization of acetic acid with sodium hydroxide, if we add excess sodium hydroxide, the conductance increases rapidly because the increase in the number of ions and also fast moving ions. So conductance increases rapidly. Then how can we get the endpoint? The intersection of these two lines gives the endpoint. Then another scenario, weak acid versus weak base. If acetic acid is taken as weak acid and ammonium hydroxide is taken as weak base, they undergo neutralization and they give some salt, acetate, so ion and ammonium ion in the salt, ammonium acetate, and it gives water molecule. Same in the beaker, we are inserting the cell, conductivity cell, to measure the conductance, and the measured conductance is displayed in the conductivity meter. We are going to add base from the burette. Here ammonium hydroxide is the base, acetic acid is the acid. So initially that acetic acid doesn't have conductance. Now we are adding ammonium hydroxide to the acetic acid. It started increasing in the number of ions. There is increase in the ions means the conductance increases, but the size of the ion here is more. So if we plot a graph between volume of ammonium hydroxide versus conductance, there will be slow increase in the conductance till acetic acid neutralizes. And after neutralization of acetic acid, if we add ammonium hydroxide, then it remains constant because there is no change in the number of ions. So the conductance will remain constant. Then the intersection of these two lines will give the endpoint. Coming to the another scenario, mixture of acids versus strong base. If we add both strong acid and weak acid and it is neutralized with strong base like NaOH, what happens? HCl plus acetic acid is going to neutralize with sodium hydroxide and they form sodium ion, acetate ion, chloride ion plus H2O. If we mix these two acids, which one will react with sodium hydroxide first? First, HCl is going to react. So if we plot a graph between volume of NaOH versus conductance, sodium hydroxide neutralizes the HCl first. So if we add sodium hydroxide to HCl, initially the number of ions decreases, fast moving H plus ions decreases, so conductance decreases rapidly. And after neutralization of HCl, acetic acid is going to neutralize with sodium hydroxide. And with the addition of sodium hydroxide to acetic acid, number of acetate ions increases. And this is bulky ion, so it doesn't move faster. So conductance increases slowly. Then after neutralization of acetic acid, if we add sodium hydroxide, then number of ions increases and fast moving ions also increases. So conductance increases rapidly. To calculate the endpoint of HCl, this is the endpoint of HCl. Then what about acetic acid? This is the another endpoint. The difference between the volume of these two endpoints will give the endpoint for acetic acid. Now, just a brief discussion between strong acid, strong base, weak acid, strong base, strong acid, weak base, weak acid versus weak base. We'll draw the graph. Just a brief revise. With the decrease in the number of ions, conductance decreases. After neutralization, again, number of ions going to increase, so conductance increases. And coming to weak acid versus strong base, initially doesn't have any weak ions. So with the addition of base to acid, number of ions increases, but conductance is increasing slowly due to bulky ion increases. And after neutralization of weak acid, acetic acid, then number of ions increases, the two fast moving ions increases. That why graph will come like this. Volume of base versus conductance. And coming to strong acid versus weak base, conductance decreases rapidly due to decrease in the number of ions. And the weak base, after neutralization, it doesn't have any ions, so it remains constant. Then coming to weak acid versus weak base, with the addition of ammonium hydroxide to acetic acid, number of ions increases, that too bulky ion increasing, so slight increase. Then after neutralization, no change in the conductance because there is no change in the number of ions. Intersection of two lines gives the endpoint. Thank you.